Good afternoon, everyone, and welcome to the last talk of the day. My name is Bram. I work at Lab Digital, a full-service digital agency located here in Utrecht. I tend to talk a bit fast, so if I talk too fast, give me a sign, let me know. I'll try to slow down a little. And today, I'll be discussing the subject of monitoring, specifically using something called OpenTelemetry. Let's dive right in, shall we? So, why do we need monitoring in OpenTelemetry? It does because our applications are complex, right? They have lots of moving bits and pieces, many things happen, many things can break. And because many things can break, we're often not sure what exactly has broken or what has gone wrong. It can be very difficult to find the source of your errors, and manually searching for them is not the most efficient way to go about things. We all want to be known as good developers, right? And as a good developer, it is expected of you that you can quickly and efficiently find and resolve issues. But it's kind of hard to predict what can go wrong. It's actually kind of impossible. And it's also very important to know whether something is broken before you get the call from customer support, before your business owner or product owner calls you and says, hey, the website is down, can you please take a look? And then you hear, oh no, it's been down for 2 hours and we haven't had any customers. So you want to know before that happens, before somebody needs to tell you. To do this, we need tools, right? We're developers, we like using tools. Luckily, there are tools. So here you can see 3 images of different groups of people operating at the top of their profession. You can see surgeons working in an operating room. You can see a Formula 1 team with a pit wall behind them. And you can see the control center for SpaceX when they launch a rocket into space. So one similarity all these companies have is they have a lot of tools to give them insight into their processes, applications, bodies, in the case of surgeons, to know what they're doing, to know what's going wrong, what's going right. Has this ever been you, right? After doing a release, have you ever lied there awake thinking, I'm not sure if I broke something. This is stressful. I definitely have been this person, and I did not enjoy it. Luckily, there is a solution. It's called OpenTelemetry. It's what we'll be focusing on today. And OpenTelemetry is a suite of tools and standards and SDKs that enables developers to monitor their projects. OpenTelemetry, or OTel for short, what it does is it tracks a series of events and it produces detail of all these events. So, for example, if I were to be thirsty and then I walk over here, I grab my water bottle, I walk back, and I have a drink while walking. That is something you can represent as something called a span, right? At the top level, we see the main process, resolving thirst. In that process, we have a section for walking, followed by a section for grabbing the bottle, another section for walking, and while I walked, I had a drink. This whole thing together is called a trace. And within a trace, you have spans. So a span is just one of these little bars within a trace that says, it took this long to do something. How about we dive into some live coding, right? It's always nicer to see some actual code examples, so let's go and do that. Let me open up my editor. I need to make this a lot. Well, actually, how is this for visibility in the back of the room? Yeah, good. I see some heads nodding, so that's always great. The current application that we have right now exists out of 2 bits. There's a front end and there's a back end. In this scenario, I'm a developer that works for a company called Fruital. Let me quickly show you the side. Made this thanks to AI. So what Fruital does is we sell fruit, you might have guessed. So this is just the homepage with a nice welcome banner. We can scroll down to our fruit selections. We sell lots of different fruits for very fair prices. some quick blurbs on why you should pick us as your favorite fruit app, and a newsletter subscription. And then there's a second type of page, the product display page, where you can see a nice image of the kind of fruit you're buying, some reviews, the name, the price, some actions to add it to your cart or wish list, and the standard product description information. So considering that I'm a developer working on this front end or on this application, I get a message from somebody in sales, Marco, telling me, hey Bram, we have an issue. Sales are down since you guys released an update last week. Can you please look into that for me? And so typically what you could do is you go through the website and you could start clicking on different kinds of fruits and seeing if you can find an issue. That, of course, is not the best way to go about doing things. It's much more efficient to use tooling. So that's exactly what we'll do, right? So what we're going to do is we're going to add Otel to our front end, and Otel will then send traces to something called Jaeger. And Jaeger is just an application that I can run locally, which will collect these traces and help me represent them in a visual way. So let's open up our code. As you can see here, the front end is actually a Next.js app, but something similar is available for Nuxt, Vue, React, whatever you have. So it doesn't really matter. Just in this example, I'm using Next. There we go. That was what I was looking for. So I need to add a new file called instrumentation.ts. I always love typing when lots of people watch me type. It's great. So this file is automatically picked up by Next.js. I don't have to do anything special for that. Export async. So what I'm doing is I'm setting up something called a register function, right? So as I mentioned, this file is automatically picked up as long as it has a function called register in there. And I can quickly call this function called register Otel. And all I need to pass it is a service name, which in this case I'll call next server. So I'm importing register Otel from Vercel Otel. This is a package. It's free and open source. You can use many different ones, whatever you like. This one works fine for a Next.js use case. So I need to quickly restart my server now. And what we can do now is we can go to the Jaeger UI. We can refresh it. And suddenly we see services pop up that we didn't have before. Right? So now we see our next server, what we just called our application. We can set the results to a bit more than 20, because that's not too many. And we can click Find Traces. All right. So I would like to draw your attention to this graph down here at the bottom. At the top. Where did I put my pointer? There it is. So you can see lots of little dots here, spread out across the graph. At the bottom of the graph is just time, over time, right? It's almost 5 p.m. now. And on the other axis, you can see the duration of a request. So what we can see, we still have a couple there on the top left, which kind of ruin my graph. But what we can see is most of our requests are nice and fast, right? So they have durations that are, well, close to 0. But some requests are a bit slower. So let's click one of these requests and take a look what's happening in there, right? So I can just click one of these little dots, and it takes me to this screen. That is, I'm going to need to zoom out a little, or else it won't fit on the screen properly. There we go. This should still be easily visible in the back, right? Fine. So what we can see here is the next server getting the request to /slug, which is just the product detail page it's trying to load. Then it's rendering that page. And then what it's doing here is it calling my API to get the fruit cherry in this case. So I would like to draw your attention to the little black bar, because that's where the time is actually spent, right? So it's doing a little bit in this top level span, then a bit more in this second span, and then most of the time is spent doing this API call. And then it goes back up and back up again to actually show the page to the user. So what does this tell us? It tells us probably something is wrong with our API call. It's taking entirely too long. So what I'm going to do, me as a front-ender, it's what I love doing best. I'm going to call the back-ender and tell him it's his problem. So, no, API is broken. Could you take a look, please? Thanks. And now, me as a back-ender will go into the code and try to see what's wrong. So luckily, my front-ender told me about this lovely thing called OpenTelemetry. I can apply it in the back-end as well. So I go back to my code. I go to my Express server. And in this file, I need to add a bit of code, which I just dropped on the ground. Oh no, and now I lost my backend. So once again, need to add a couple of lines of code, not too much though. What I'm doing is I'm importing the Node SDK from actual at OpenTelemetry. So again, completely open source. I need to set up a quick bit of instrumentation. This will provide me with some standard traces. Just as in before in Vercel, we saw a couple of standard traces, right? We saw standard traces for the page being loaded, the page being rendered, and API calls going out. In this case, I'm adding standard traces for Express, just the endpoints being called, for example. Nope, I already did that. And again, I need to add a service name. That's all I need. It's that easy. So what we can now do is we can go back to Jaeger. We can refresh the page. We can get some more traces. And let's go to one of the slow ones again. That didn't do what I hoped that would do. Always awkward. Yeah, let me try refreshing the server. Yeah. Yeah. Because when you create something, you have to actually use it, right? SDK.start, there we go. Let me refresh the traces real quick. It's the joys of live coding, isn't it? There we go. Now we see more traces. This one isn't great. I'm going to look for a prettier one. That's nicer, right? So we can see nearly the same thing as we saw before. We saw the next server getting the call, it rendering the page, it doing the API call, but now we do see the nice long bar in the API call. So we can confirm, yes, something is going wrong inside of our Express server. But we don't really know what, right? So a nice feature of OpenTelemetry is that you can add spans yourself, right? Because, like I mentioned, we now have a bunch of default spans, but we can add our own custom spans as well. So we know that something is going wrong in this fruit endpoint. So we'll just add a span around it to see if it's actually this database call that might be the issue, right? Because database calls can be slow, maybe we have a really poor join somewhere. Let's take a look, and rather than guessing, have actual data to know what's happening. A bit of boilerplate. So typically I would put this in a nice utility somewhere that you don't have to do this much boilerplate. But just for this use case, for you guys, I just want to show how actually easy it is to do. Got to do the import. And we're almost there. Not too much longer now. Well, I actually specifically turned off Copilot to not have any noise from Copilot. So now we have a span. All we need to do is move the actual call to the database inside of there, return it, and not forget to end our span after we've returned it. It's not happy with me. All right. Important thing, right? I have to add a name for our span. Let's call it database get fruit. So we've added a custom span. Let's go back to Jaeger, see if we can see it. So these trays are not very pretty. I was hoping to get a much nicer one. So let's refresh again. Click this bad boy. That's what I was hoping for. So once again, we can see that the new span we added, database call, is in fact the issue. DB get fruit is where all our time is spent. Let's get this resolved finally. Take a quick look at our database. Does anybody see the issue in this code? Classic, right? It's the best way to get performance upgrades. Just remove the sleep you had in there. So I removed it. Let's go to Jaeger. Look at our traces. And look, all of our traces are now nice and fast. No more stuff bubbling up, only fast traces of a couple of milliseconds. So yay, we fixed our performance issue. Well done. Our sales guy, Marco, will be happy. He'll be getting his yearly bonus again. What we can do is just bring them back, and we should see the traces increase again. So far, I've been using this tool, Jaeger. Jaeger is nice. You can run it locally, but it doesn't give too much information. It simply helps you kind of see durations, and then you can click through, and that's it. There are many tools which will allow you to do a lot more. One tool I like to use is Honeycomb. So what you do is, instead of sending your traces to Jaeger, you send your traces to Honeycomb. That's really all you have to switch out. Let's quickly take care of that. So this time I'm not going to type, because you're all probably tired of seeing me type. In this case, I'm just going to copy it over. So all I'm doing in this case is I'm adding 2 lines of config, the API and the API key. And in the front end, oops, that's the wrong folder. I'm adding 2 process, what they're called? Environment variables. That's the one. That's all I need to do. In this case, to not send them to localhost, but to send them to Honeycomb instead. Of course, I have to... It's not happy. There we go. It's happy again. Restart my servers real quick because I'm picking up env variables. Nope. Oh, right. I broke it again. There we go. It's fixed. Yeah, we can see the requests coming in again. So what we can now do, I'm going to zoom out a tiny bit here. I think this should still be visible, right? I'll just show you what we had a while ago. What I can just do is visualize the average of the duration everywhere where the http.url exists. And I would like to see them grouped by http.url. So what we can see now, right, is this beautiful graph that shows, hey, we have a bunch of fast requests and we have some slow ones, which is the blue ones. And down here in the table in the bottom, we can see that in fact, yes, cherry is the slow one, the rest is fast. So using this before would have immediately pointed us towards cherry being the problem. It's a nicer way to group data, to sort data, because you can just do various queries and groups. So we were happy that we fixed our issue, right? But salespeople are never happy, in fact, because they immediately found a new issue for me. He's saying, hey guys, the lemons are not selling well. Could you please look into that for me? So an important thing to know here is about something called core web vitals. If you guys were at Sander's talk this morning, not sure if he's here somewhere, he talked about core web vitals, and core web vitals actually affect your Google search page, Google ranking, right? If your core web vitals are bad, Google will list you lower on the searches than it would if your core web vitals are good. OTel can help us see if our core web vitals are good. So you could run, what's it called, Lighthouse in your browser, but you're all probably familiar, right? Every time you run Lighthouse, you get kind of different results. And then you only get results from one machine. If you run it using OTel, you can get it from everyone's machine. And you get way more data. So it tells you a lot more about what's happening. So we'll quickly do that. So I have this file already set up. Here, called client-side instrumentation. Again, not typing it out because it's a bit more. But effectively, what it does, it's just a React component called client-side instrumentation, which starts this function, which is up here on line 9. And I'd like to draw your attention to this line, where I'm saying, hey, please track these core web vitals. All I need to do to get this started is have it here in my layout, client-side instrumentation, and it'll become available in Honeycomb, just with my traces. So let's have a look, shall we? I can go to my client. I will clean this up a little, just to see if we have any traces. We do, lovely. So our sales guy was saying something about the lemons not selling well. So let's take a look at the lemons. So we can just filter on lemons. See all these traces. And in this case, let's focus on CLS, which is one of the core web vitals. So we only want traces that actually have a CLS rating, and we would like to group by CLS rating. So what we can see is that most of our traces for lemons, for CLS, are actually quite bad. So for those of you who might not know, CLS is compound layout shift. It means that something is messing up your content by moving it around after the browser has initially rendered. It's a very annoying use case. I mean, you all probably know it, like when you go to a page and you want to click a button, and just as you go to click the button, the whole thing shifts down. Very annoying. You shouldn't have it. That's why Google ranks it. So we see here, right, it's on our lemon path. So let's have a look, actually, at our lemons. Yeah, that's not great. Somebody added a bunch of banners, and when the page loads, it pushes everything down. I mean, I guess we shouldn't blame the business because they don't know any better. We as developers should have fixed this. So let's take care of it, right? Let's go to our page. Where is it? This is the backend, it's not there. Our product detail page. And let's look for our notifications. This is our notification component. Let's go into it. What we see is that it uses relative positioning. Probably not the best idea. Let's change that over to fixed positioning. Take a quick look at the page. What we now see, it no longer gets pushed down. It just nicely lies on top of each other, on top of the page. Much better. Let's see if we can actually see these results in Honeycomb. So yeah, we can actually see the ratings improve over time. And we are now getting many more good results than we were before, where we had mostly poor results. So something that's regrettably nicer to show you with a screenshot than actual code is something like dashboards, right? In order to have a nice dashboard, you need to have a ton of data in there, which I don't actually have for this demo. But so I have shown you some queries, which you can do nice and quick. But oftentimes it's nicer to have a dashboard prepared to go that you can just load and see exactly what's happening. So what you can do is you can just prepare a bunch of queries, put them on the dashboard, and then just load that dashboard ready to go. So this is an actual production dashboard we use, where we track our core web vitals. We have a nice chart there in the middle, where we have all of them stacked together. Hopefully we can reach the 100, so we're going to get the max ranking. And then, for example, we do some scores per page type, right? You definitely cannot read this from the back. I can barely even read it from here. But for example, you can see that the login page has a bit of a CLS issue. Like it's at 99.8, it's not bad, but there's some tiny thing that we might probably want to fix. So this kind of thing helps you easily find issues without having to do the queries each and every time. Another nice feature is release markers, right? So this is the graph I just showed you. But here in the middle, you can see a release marker, which is great, because when things tend to break after a release. So now this will immediately show you when the release has happened, with the exact version of that release, helping you find issues that are caused by releases. So in this case, what you can hopefully see is pre-release, we had a total score of about 85, and it immediately dips after release. So this was something we were a bit confused about, right? Why do releases cause a dip in all of our scores? Until we realized it's our cache. We don't pre-build any pages, so every time we do a release, we fully delete our cache, and we have to start again from the bottom. So yeah, this is something we need to work on. Keep our cache in some way. Haven't found a solution yet, but at least we know, right? Another useful thing, which I like a lot, are triggers. At the start, I mentioned that we as developers should know if something is wrong with the site before somebody calls us and tells us, right? But you're not going to sit there and spam the refresh button on your dashboard all day long to see if something has gone wrong. So triggers, what they do is they help you get alert notifications. They can tell you, hey, So in this case, what I did is I set up a trigger for average duration, grouped by URL, and I said here at the bottom, hey, if the average duration goes over 2,000 milliseconds in a 15-minute time window, please let me know. I want to know. And in this case, you can send triggers of alerts to, I know, Teams, Slack. You can have somebody message your phone, your dyno, whatever, anything you want. It's just webhooks. So it's a great way to get notified if there's actually issues. So we have a ton of these triggers set up in production, and they've actually saved our bacon once or twice, letting us know, hey, something has gone wrong. You need to go fix it right now before anyone from the business has to call you. To summarize, software is complex. You should use tooling to get insights in your issues. You shouldn't just click through your website, hope you can find the issues. You should be able to proactively find issues before somebody tells you they are there. We have found several that we would have never found otherwise just to using this kind of tool. OpenTelemetry is a tool that you can use to find issues, answer questions, and catch problems early. It is the standard for this kind of work, and you should check it out. And hopefully, as I've shown with my quick code examples, adding an OpenTelemetry is actually kind of easy. Just to get started, you don't need much. A couple of lines of codes here and there is enough just to get the basic insights. There are plenty of open source tools that you can use. There are plenty of SaaS partners that you can send your traces to, but you can also easily self-host a trace collection and UI solution if you want to. Thank you all for your attention. Let's have a beer.